Hello and welcome to Module 1 in our Python series. We're going to begin today's session by talking a little bit about the Python language as well as about the creator of Python. We'll then download the software and work with the Python shell in order to understand some of the basics of Python. So let's begin with what is Python. And as you may know already, Python is a computer programming language. It is one of the most popular languages in the world today, mainly because it's easy to use and it's easy to learn as well and easy to maintain as well. It's used by many major platforms today, including Google, Facebook, Instagram, Spotify, Netflix. You can think of any platform and they're probably using Python for some functionality or the other. Just to give you a glimpse of why these platforms prefer Python, Google has a philosophy, Python where we can, C++ where we must. Dropbox prefers Python because of its support for various platforms, ease of learning, and easy readability as well. Coming to the creator of Python, Python was designed by Guido van Rossum in 1989. He's a Dutch national. He was born in the Netherlands, of course, studied at the University of Amsterdam, graduating with a master's in mathematics and computer science. His first project was working on a language called ABC. He also worked on a distributed operating system called Amoeba. Guido van Rossum had the idea of creating his own language that could be extendable, meaning a language that other developers could contribute to in terms of its growth. And so in the Christmas holidays of 1989, he started working on Python as a side project. Now, this is Guido van Rossum, right? So he started working, as I said, on Python in the Christmas vacation of 1989. He then went to work for a non-profit organization in the US before being hired by Google in 2005. He worked with Google until 2012 and then went on to work with Dropbox in 2013. Now, all this while, Guido van Rossum was the benevolent dictator for life at the Python community. Now, one may ask, what does this title actually mean? So, this title is normally given to an individual who is a founder of a major project and then builds a community around that, right? So that's pretty apt for Guido van Rossum. He built Python on his own and then built the Python community around that. So he remained a benevolent dictator for life until 2018, when he stepped down from that position and the title was then eliminated from the Python community structure. Okay, and remember the BDFL, or Benevolent Dictator for Life, that title is only applicable if an individual, founded the project. If a company did, then of course the company would have a formal organizational structure, right? So it wouldn't apply there. But anyway, Guido van Rossum continued to work with Dropbox, as I said, until 2019, when he went into retirement. But then he came out of retirement in 2020 and was hired by Microsoft. And today he works with Microsoft as a distinguished engineer with the developer team. Okay, so that's the story of Guido van Rossum. Now, Python is written in the C language. It is object-oriented, so everything is an object and created using what are called classes, and we look at this as we go along in the series. Python uses an interpreter and is a high-level language. Now, here you need to understand two terms, mainly what is an interpreter and what is a high-level language. Right? We'll talk first about the term high level language. For that, we need to understand that in computer software, there are various levels of languages. So you have low level languages, you have middle level languages, and then you have high level languages. Now, low level languages, though the term may be deceptive, are the most difficult to understand, right? They're very close to the hardware, and examples are machine language and assembly. So what do I mean when I say they're very close to the hardware? So for example, with assembly language, you can actually program the computer microprocessor. Okay. Machine language is the only language that computers understand. It is a series of ones and zeros. You can consider them to be on and off switches. So the 1 would signify an on and the 0 would signify an off. Remember that a computer is an electronic device at the end of the day, right? Coming to middle level languages, those are less difficult to read and understand when compared to low level languages. And the best example is C. So middle level languages are between low level and high level. As I mentioned earlier, they're not as difficult as low level, but they're not as easy to understand as high level languages. And then we have high level languages, which are easy to read and understand for us humans. They're created to be user oriented, and examples are Python, Visual Basic, and COBOL. Now, whatever code we write, whether it be assembly language, middle level languages like C language, or high level languages, the code has to be converted to machine language, because remember, machine language is the only language computers understand. Now, with assembly language, there's something called assembler, which is a software again that converts assembly language to machine language. In the case of middle and high level languages, there are two types of software that do the same job. One of them is called the interpreter, the other is the compiler. Now, the way the compiler and the interpreter works is different. So let's look at some of those differences. Compilers translate the entire program. So they take the entire source code, convert that to machine language in one go. Interpreters will translate the program one line or one instruction at a time. In the case of compilers, errors are shown at the end of the compilation process, right? That makes debugging a little more difficult when we compare that with interpreters that show errors after every line. So debugging is easier with interpreters. In the case of compilers, execution time is faster. And when we're talking about execution time, we're talking about the time it takes to convert the code into machine language. So that is faster with a compiler, because remember, the compiler is converting the entire batch of instructions, whereas the interpreter is converting a line at a time, and that makes the process of converting to machine language a bit slower. Compilers convert source code to object code, right? Object code being machine language, and therefore need more memory. Now, there's something we need to understand, that once the compiler creates an object file, that's not something that we can execute. Okay, there's another process that needs to happen before we can execute, and we'll come to that in the next point. So for now, just remember that compilers convert source code to object code. They need memory to store that, right? Interpreters do not create object code, and therefore they are more memory efficient when compared with compilers. With compilers, as I said earlier, they create object code, right? And now why they need that object code to be created is because it's followed by what is called a linking process. And the linking process involves incorporating references to libraries that we may use in our code. With interpreters, there's no concept of linking. With compilers, because we've already created object code, and that then is used to create executable code. There is no need of the source code. In the case of interpreters, because they are directly converting each line of code to machine language and executing it, right, they need the source code to be available throughout the process, right? Examples of compiler-based languages are COBOL, C, C++. Examples of interpreter-based languages are BASIC, Python, and Ruby. Now we need to, of course, download the software. So all you need to do now is go to your browser. Okay, I'm going to be using Chrome. You can choose whichever browser you want to use and just type in Python download in your search bar. Right? And this is the link. Click on the link and you'll see the same screen we saw on that slide. If you're using Windows, I suggest you download this version, right? Of course, if you're using other operating systems, download the one that's relevant to your computer. Now, once we click on this link, you will see there's a file that is downloaded. And you can see this file in your downloads folder, right? And once you click on that file, remember this is an executable file. So once you click on it, of course, your computer will ask whether you want to allow the software to make changes to your machine. You can agree to that, of course, and then you'll see this screen, right? Now we are going to select install now. We don't need a customized installation, right? When we select this option, the download will include IDLE, which is Python's built-in IDE, that is the Integrated Development Environment, pip, which is preferred installation program, and we need pip in order to install Python modules later on in this series, and of course the documentation. So that's the option we will select. What's important is that you also tick this option, add Python 3.9 to path. This is the Windows path variable. And why this is important is because then we can access Python from any directory on our computer. So just make sure you do that, and then of course let the installation continue. Right? Now you see how the shell works, right? Python shell will wait for us to type in some line of code, and we'll read the line of code, evaluate it, print the output, and then wait for the next instruction, okay, or next line of code to be typed in. Coming to the basics that we will look at today, we will start with strings, then numbers. We'll talk about variables. For those who are absolutely new to software, a variable is a space in computer memory where a value is stored. So if, for example, I say x equal to 100, right? Consider x to be a little space in memory where the value 100 is stored. Okay, and computer memory can be considered to be a grid with each little box on that grid representing a memory space. Okay. After variables, we move on to data types. Now, strings and numbers are data types, but Python has other built-in data types like lists, tuples, sets, dictionaries. We'll be looking at lists and tuples today. The rest of the data types we'll look at later on in the series. We then will talk about loops, but specifically today we'll just talk about the while loop. And then we'll talk about operators as well. Now coming to Python operators, we have arithmetic operators, and these are similar to what you see in mathematics: addition, subtraction, multiplication, division, exponentiation. We also have something called modulo and flow division. So we look at all those today as well. There's logical operators that we will look at, comparison operators. Now, comparison operators you would be familiar with: greater than, less than, greater than, equal to, less than, equal to, not equal to, etc. So we look at comparison operators as well today. Assignment operators, right? So when I say x equal to 100, like I said earlier, that is an assignment operator. There are some more which we look at as well. And membership operators are in and not in. So we look at those. And finally, we have bitwise operators. Okay, so now I hope your software is installed. To access the shell, all you need to do is in your Windows search bar, if you're using Windows, that is, just type in Python, and you can either press enter here or click on open. That will give you this shell. Okay, so that's the Python shell. This is called the primary prompt. There is also a secondary prompt which we'll come to later. Okay, so now we start with strings. All strings need to be enclosed within quotes, right? Like that. The Python shell will evaluate what I've typed in and then give me the result. What's important to remember is that every string in Python is an array. And again, for those not familiar with arrays, arrays would be contiguous spaces in memory. Okay, and each of those spaces can be accessed using what is called an index. So for example, I could say here, let me store this string in a variable, so that makes it easier. Let's call it string 1. You can call it anything. That's a variable name, equal to, and I'm using the assignment operator here, hello, right? So now if I just type in string 1, the Python shell will evaluate and show me the contents of string 1. Right, now I can say string 1 of 0. This is how I access the elements in the array. Okay, and 0 would be the index that I spoke about earlier. So in terms of 0, that's always the first element in the array. If I say string 1 of 0, now it will show me H. String 1 of 1 will show me E. Right? If I say string 1 of 4, it will show me O. And this brings me to an important point. As I said earlier, every array, or rather in every array, the first element will always have the index 0. Okay? The last element will be the length of the array minus 1. What do I mean? So if I say, for example, len, and here I'm using a built-in function len, which will give me the length of string 1. Okay, and that will tell me it's 5 characters long. So there are, as we know, 1, 2, 3, 4, 5 characters, but in terms of arrays, the last element, or rather the index for the last element, will be the length of the array minus 1, and therefore 4. If we ask for string 1 of 5, for example, we will get an error saying string index out of range. Okay? Right, so I hope that's clear. It's important for you to understand this, because later on when we are manipulating strings, we need to make sure that even when we are using a loop, that we don't go beyond the last index for that particular string. or we will have errors, right? Now, we could have a longer string. For example, I could say hello from the world of Python. Okay. And of course, if I just type in string 2, it will show me the contents of string 2. I can type in len of string 2, right, and tell me there are so many characters in the string, right? I could also, for example, say string 2 dot capitalize, okay, and that will give me the first character in uppercase. Similarly, I could say string 2 dot upper, right, that will show me the entire string in uppercase. String 2 dot lower will show me all the characters in lowercase, right? Now I can do one more thing. I can, for example, select just a part of a string or extract a substring. Okay, so let's try it with both string 1 and string 2. How will I do it? I'll do it with string 1 first. If I say string 1, right, and then I specify which character I want to start from. So let's say I want to start from 1, and then I say until 3. Now let's see what I get. I get E and L. So remember, it's going to the second position. Remember that index 1 is the second position in the string, right? And then of course we have index 2, which is L, right? I hope you understand that. So we have 0, 1 and 2, right? And of course 3 is not included. Okay, if I wanted the third element as well, then I would say 1 to 4, and in that case it would give me ELL. I can do a similar thing with string 2. String 2, let's see, 1 colon 10. Okay, and it will show me these, right? So that's at the first index. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 10 is not included. Okay, so that's how I can extract part of the string, and this is referred to as slicing. Okay, now I can do one more thing. I can split this string, for example. So I can say string split equal to string 2 dot split. Split is a built-in function again, and by default it will split it on the basis of the space. So if I look at string split now, right, you will see that every word as I know it is a separate element in what is now a list. How do we know? Okay, let's use the type method. So if I say type of string 1, Python will evaluate and tell me it's of class str. Okay, str, remember, is an object. Objects are created using classes. Type of string 2 is also class str. If I say type of string split, right, and tell me it belongs to the list class. Remember, list is also an object. Okay, now the difference between the class str and the class list is that I cannot add something to class str. So if I try something like this, if I say string 2 dot append, and again append is a built-in function, and I say Python is easy to learn, okay, I will get an error saying the string object has no attribute append, right? Okay, so we cannot add. But if we, for example, try to add to the split string, so string split, remember string split is a list dot append, right? And I use the same string. I say Python is easy to learn, okay, and now I look at string split. You will see that it's added this as another element, okay. So if I now look at the length of string split, it will include the one I added. Okay, so that's the difference between lists and strings. Now again, with strings, I can look at them in the reverse direction, or I can ask for a string to be shown in reverse. How do I do that? Again, by using slicing, right? I can say string 1. Let me just scroll down a bit so you can see. So string 1 colon beginning end, but in reverse, okay, and it will show me the string in reverse. I can do the same thing with string 2, right? So string 2 beginning end -1, and you see how it's reverse the entire string. Okay, you can also do the same with the split string, right? Also, you can use these negative numbers, okay, for extracting a part of the string. How? I can say string 2, for example, right? And I can say minus 4 until -1, okay, and it will give me these 3 letters. You understand what it's doing? This is -1, right? Okay, let's not look at string split. Let's look at string 2, right? So this is -1, this is 2, this is 3, this is -4. It's going to that character or that element in the string, and then counting -3, -2. Remember, it does not include the element that is specified here, right? I could say string 2 of -1, and then I will see that particular element. Okay, so this is how you would use negative values. You can also use it on split string, for example. So I could say string split and then -4 until -1, and you see I get those, right? -1, -2, -3, -4. Okay, so I hope you understood how we can extract parts of strings, right? So just to recap what we did with strings, all strings have to be in quotes. And again, we can use single quotes or double quotes, both are fine, right? We can then ask for the length of a string, because all strings are arrays in Python. We can use built-in functions like capitalize, upper, lower, right? We can also do slicing to extract parts of strings, and we can use positive as well as negative values with slicing, right? We could also reverse a string. We can also split a string, but we cannot append to a string. When we do split a string, what we get is a list, right? And then we can append to that list, right? Now I could have a string like this. Okay, let me call it string 3 equal to, it's a wonderful world coding with Python. Okay. Now I am presented with an invalid syntax, or a syntax error which says invalid syntax. What's the invalid syntax here? I have a mismatch of quotes, right? I have this quote and I have it matched here, but then I have another one. So Python is pointing that out to me. Now, in order to take care of this error, what I do is I use an escape character. So I can say again, and by the way, you don't need to type in, you can just use the up arrow, you get the previous command. Just before that quote, I can just use a backslash. And now you see I don't get the error. And of course, I will see my string. The other way is, of course, how Python has showed us just now. You can use double quotes with the single quote inside, right? We can also join, or the technical term is concatenate strings, right? And how we do that is, we can say string 4 equal to string 1, let's say string 2 plus string 3, right? And then if we look at string 4, we will have the joined strings. And of course, if you want a space there, then what you will do is you will just put in the space, right? So plus, and then just that space and the plus sign again. Okay. Right, so this will now give us the string spaced out. String 4, and you can see that's nicely spaced out. Right, so that's concatenation. Okay. Now we could have a multi-line string. To have a multi-line string, let's call it multi-line string. You can name it whatever you like, equal to, but for a multi-line string, you need to use 3 double quotes. Then we can type in Python is named after the famous British comedy series Monty Python's Flying Circus, and this is a fact, by the way. Okay. And then I want to go to the next line. Press enter, and that's now my secondary prompt, the ellipsis. Okay, it shows continuation. So now I can continue typing. I can see the Python documentation contains many references to this television series. Maybe I want another line. developers are encouraged to include references to the same TV series when contributing modules to Python. And now let's say I want to end my multi-line string. So those 3 double quotes will end it. Okay. Now when I look at multi-line string, you can see it has 3 sentences I typed in, and those are separated by this \n, which is the carriage return, or in layman's terms, the enter key. Okay, now I can split this string, so I can say split multi-line equal to multi-line string dot split, and I can use that character to indicate how I want this multi-line string split. So when I say split multi-line now, now I have this list with the elements in it, right, split on the basis of this character, the \n. Len of split multi-line will show me how many elements there are here. So there are 3. Remember that if I say type of split multi-line, okay, then I get the class list, belongs to the class list. And of course, because it's a list, as we did earlier, we can add to this, right? So I hope you've understood what we've done here with strings. While we are talking about lists, I'd also like to talk about now tuples, and this is just a simple introduction to these 2 data types. We look at them in more detail as we go along in the series. So let's first create a list of our own, and then we'll create a tuple of our own, and then we'll see the differences between the 2. So list 1 equal to let's say apples, oranges, lemons, pineapples. Okay, and note how we need to use box brackets. Also note when my string is split, I get these box brackets. Okay, so now when I press enter, my list is created, and I can say type of list 1, and of course you could name it anything, right? I could call it fruits, for example. I don't need to name it list. Determine belongs to the class list. Okay, and of course, because it is a list, I can append to it, right? So list 1 dot append, and I can say strawberries. And now if I look at list 1, it will include what I appended to the list, right? Now let's look at tuples. So let's say tup1 equal to, but here the brackets are different. Okay, and I can use the same. So oranges, lemons, peaches, pears. Okay, and let's leave it at that. Now if I say type of tuple 1, you tell me it's a tuple. So what's the difference between lists and tuples? One, of course, as I mentioned earlier, is the way we write them, right? The brackets here are different. But again, I cannot add to the tuple. So if I try tuple1 dot append, and let's say raspberries, right? But tell me tuple object has no attribute append. So this brings us to an important point. Tuples are immutable. That's an important term to remember, meaning they cannot be changed. But lists are mutable. Okay, lists can be changed. Right, so that's about tuples and lists. Now I think we've covered most of what we wanted to do with strings today. I'm going to move on to numbers. Okay, so now with numbers, I can just type in 100 like that, and Python will evaluate and tell me, yes, you typed in 100. Okay, I can say 100 plus 10, and it will give me the sum. So I can use it as a calculator. 100 multiplied by 3 and give me the result. 100 divided by 2, right? It gives me the result. But here it gives me the result with the integer part as well as the decimal or the fractional part. Okay, if I don't want the decimal or the fractional part, I can use what is called flow division, which is 2 or forward slashes or a double forward slash, and then I get just the integer part. Okay, now I can also use exponentiation, so 10 raised to 2, 100, right? And of course I can combine these operations in one expression, right? Okay, so I can do something like this: 6 divided by 3 plus 5 minus 2 raised to 4 minus 3, right? And I will get the result. Okay, so how is this expression being evaluated? First, the exponentiation will be done, right? So 2 raised to 4, right? Then the division will be done. So that's result is 2, right? Then the addition and then the subtraction. Okay. Now, of course, I could have another expression like this: 3 plus 5, right, minus 8 divided by 2 raised to 2 minus 1. Okay, and I'll get a certain value, right? I could, for example, use brackets to change the order in which this is evaluated, and then I will get a different result, right? You know how the arithmetic board mass works, right? So brackets are given preference, and then of course we have exponentiation, then multiplication and division. and then addition and subtraction. Right? So you can change the order of evaluation using brackets. Right? So I can say here 3 plus 5 minus 8 divided by 2 raised to 2 minus 1. And then I get a different result. Okay. So now we've looked at arithmetic operators: plus, minus, multiplication, division, floor division. Let's look at modulo now. So if I say 100, percentage, that's the modulo sign, 2. What does this operator do? It will give me the remainder of the division. Remainder of the division 100 by 2 is 0. But remainder of the division 100 by 3 will be 1, right? Because 3 33s are 99 and then we have 1 left. Okay, so that's the modulo operator. Right, so now we've looked at most of the arithmetic operators. We'll now look at types, right? So if I say, for example, num1 equal to 100, and if I say type of num1, tell me it belongs to the class integer. If I say num2 equal to 100 divided by, let's say, 4, and if I say class, type of num2, tell me float. Why? Because if I look at num2, and you know, division gives me both the integer and the decimal, right? Or the fractional part. And therefore that is float. So now there are two types we are learning. There's the integer type and there's the float type. There is one more type with numbers, which is the complex numbers, but we'll look at that later in the series. Okay. Right, now let's move on to assignment operators. We've already looked at one, which is equal to. I can say num1 plus equal to. So that's also an assignment operator. Let's say 100. So what this will do is it will add 100 to num1 and store it in num1. So the end of this operation, num1 will be 200. 100 plus equal to 100. It's like saying num1 equal to num1 plus 100, but this is a more efficient way of doing it. Okay, so I can say num1, okay, and then I can say plus equal to underscore. Now what this will do is, let's look at num1 now and then I'll tell you what it's doing. So num1 now will be 400. So what Python is doing is it's adding the previous printed result and then storing that in num1. Right, so I can say here again num1 plus equal to underscore. What do you think num1 is now? You can see that it's added the 400, so now it's 800. Okay, similarly I can use minus equal to. So I can say num1 minus equal to 100. Okay, and then num1 will be 700. Okay, I can say num1 multiply equal to 2, and then num1 will be 1400. Okay, similarly I can use divide equal to, flow division equal to, right? Those are all assignment operators. Okay, so I can say num1, for example, flow division equal to 2. So what will happen here? We'll divide num1 by 2 and store the result in num1. Right? So now num1 will contain 700 because it was 1400 divided by 2. Okay, so I hope you get the idea. So this is our assignment operators. Now let's look at comparison operators. So let's see, if I type in num1 greater than num2, Python will evaluate, check if num1 is greater than num2, and give me a true or a false. Okay, similarly num1 less than num2, again Python will evaluate, tell me no, num1 is not less than num2. Okay, I can also use the not equal to. So num1, let's do equal to first. So num1 equal to, and this is a double equal to. Okay, num2, and again it will give me a false. Num1 not equal to num2, true. Okay, so these are all our comparison operators. Right? We also have greater than equal to and less than equal to. So let me use those in an if statement. So if I say if num1 greater than equal to num2, and we require a colon there after the if statement, and then we require to indent. If we don't indent, Python will tell us expected an indented block. So indentation error. Python is very strict on indentation. Okay, so here I will say again, if num1 greater than equal to num2, then I will put in a tab space, right? And we'll say print true, or yes, that's true. Else print no, that is false. Okay, it says yes, that is true. Right? Okay, now let's look at logical operators, and there's 3 of them. There's and, not, and or. Okay, so I can say here if num1 greater than equal to num2 and num2 less than 100. Okay, then, and remember the indentation, print yes, that is true. Or let's give it another message. Let's say num2 is less than 100. Okay, sorry, my mistake. Let's scroll down a bit. So if num1 greater than equal to num2 and num2 less than 100, print. Did you spot the error there? I have a different type of code. Okay, so print num2 is less than 100, right? Else print num2 is not less than 100. Okay, and now Python will evaluate and tell us num2 is less than 100. Okay, right, because both the conditions have been fulfilled, right? If with the AND operator, if one of the conditions is not fulfilled, then you know, basically it will drop down to the else. Okay, if for example I use the OR operator, so if num1 equal to 100 or num2 equal to, or let's say less than 100, okay, print true, else print false, right? And what will it print now? True. Okay, so either of these conditions have to be met. That's the OR, and then we have the NOT. Now of course I'm using very simple examples here just to just for you to understand, but later on you can combine these and or a NOT in a complex expression, right? And that we'll see in a later session, right? For today, just understand that with AND, both conditions have to be met. With OR, either of the conditions need to be met. And then we have the NOT. So if not num1 equal to 100, right? Print yes, num1 is not equal to 100, right? Else print no, num1 is equal to 100, right? Okay, and of course Python will evaluate and tell us that num1 is not equal to 100. So that's a simple explanation of our AND, NOT and OR. I hope you've understood those. Now we've looked at, let's see what we've looked at and what we've missed out. So we've looked at arithmetic, logical, comparison, assignment. Now we need to look at membership and bitwise. So we start with membership. And membership is something like this. Let me just create a tuple for this one. Tuple equal to, and let's use numbers here, 100, 200, 400, 500, and that's all. And now I can use the membership operator in. So if 100 in tup or tup2, whichever way you want to pronounce it, we say print yes, 100 is into 2, right? Else colon print no, 100 is not found. Okay, right? And it says yes, 100 is in 2 or tab 2. Similarly, you can use not in. So if, let's say, 400 not in tab 2, right? Print yes, did not find 400, right? Else print no, I found 400. Okay, you say no, I found 400. Now we need to discuss bitwise operators, but in order to understand those, we need to first understand binary. Okay, so let me just show you what the binary system is like. That's the binary system. Remember, in the decimal system, we would have the base 10. So 10 raised to 0, 10 raised to 1, etc. Right? Here's 2 raised to 0, 2 raised to 1, etc. Now, if I told you I need the binary of a number 97, how would we find that? I'm going to use Notepad for this. You can follow with me or you can do the same with me, right? So let's say 97 in binary. What we do is we say 97 divided by 2. 2 goes into 97, that's 48, right? That's 96 with a remainder of 1, right? Then we have 48. So we take this number and then divide that by 2. That's equal to 24. Remainder is 0. Then we take 24, divide by 2. That's 12. Remainder is again 0. We take 12, divide by 2. That's equal to 6. Or 0, 6 if you like. Remainder is again 0. Then we take 6 divided by 2. That's equal to 3. Remainder is again 0. Then we take 3 divided by 2. That's equal to 1. Remainder is 1. And then we take 1 divided by 2. And then we have 0. And we can't go beyond 0. But the remainder is, of course, 1. Okay, so keep this in mind. Now we have 1, 0, 0, 0. That's 4 zeros. And then 2 ones. And now, if I minimize this and show you the binary, you will see we have the same result. So let me just bring up what we did just now. So you see here 1, 0, 0, 0, 0, right? And then 1, 1. And of course, the last position will be 0. Now this makes a byte. 8 bits make a byte, right? And that represents 97. Okay. Now, how do we know this is 97? We can calculate, right? 2 raised to 6 is 64. 64 plus 32 is 96. Plus 1 is 97. Right? Now, can we do this without division? Let me give you a simple example. What if we had to find the binary of 11? How would you do it? Now, of course, you wouldn't go to 2 raised to 4, that's 16, beyond 11. So you would say, okay, 2 raised to 3 is 8, right? And I need 3 more. So 8 plus 2, 10, plus 1. That means these would be on or 1, and the rest would be off, right? What about 27? Where would I go now? I wouldn't go to 32. I would go to 16 to raise to 4. So this would be on. 16 plus 8 is 24. So this would be on as well. I need 3 more, right? So I can have this one on. So that's 24 plus 2, 26 plus 1, 27. So these would be on, the rest would be off, right? Okay, now coming to what if I use a bit shift operator? So here I'm saying shift the bits to the left. This is a bit shift to the left by 1. So 1 bit to the left. What happens then is that this 0 will then be moved out and the 1 comes here, this one comes here, 0, 0, 0, 0, 1, and then this of course becomes 0. But as you may have figured out already, the value changes, right? So 97 bit shift to the left 1 will give me the value 128 plus 64, right? That's 192 plus 2, that's 194. And you can double check this on your terminal or the Python shell. And we can see here 97 shift to the left bits by 1, and you see it gives you 194. What if I shift it to the right? 97 shift to the right 1, that changes to 48. Now let's see if when we work it out we get the same result. So if I say 97 shift to the right 1, what happens now is, of course, we don't compare it to this one. We need to compare it to the original, that's 97, right? Because this is 97 already shifted to the left by 1. So now this one goes out, right? So then you have 0, 0, 0, 0. You have the 1 coming here and another 1 coming here. And then, of course, 2 zeros as is shown here. And so our result is 32 plus 16, right? And that's 48. Okay. Now you can also use bitwise and bitwise or. There is bitwise not, but I'm not going to discuss that today. Okay, because that involves talking about signed and unsigned integers. So I'll look at that somewhere later in the series. But for today, we just discuss the bitwise and or. So now I have 97 here in binary. I have 98 in binary, and I'm sure you'll be able to work this out on your own now. You can use the same method we used here, right? Or you could try to figure it out without doing that. Okay. Now, if I say 97 and 98, what happens? What's going to happen is wherever there is a switch on or wherever there is a 1, there needs to be a 1 in the same position for 98 as well. So here you can see there's 1 here and there's 1 in 98 as well. Similarly, there's 1 for 97 here and there's 1 for 98 here as well. So 1 and 1 gives me a 1 and 1 and 1 gives me a 1 again. Now here I have 0 and 1, so that's going to give me a 0. Similarly, I have 1 and 0, that's going to give me a 0. And of course, all the rest are 0. So 97 bitwise and 98 gives me the value 64 plus 32, that's 96. Let's double check that in our shell. So if I say 97 bitwise and 98, I'll get 96. Okay. And then of course, we can do an OR operation, bitwise OR. For the bitwise OR, for example, you've got 1 here and you've got 0 here, this would be a 1. So either of them needs to be 1 for there to be a 1 in the result, or either of them needs to be on for the resultant bit to be on. Okay, so this is 1, this is 1, these are zeros of course, and then you have 1 and 1 here as well. Okay, so what will be the value? 64 plus 32, that's 96. 96 plus 2 is 98, plus 1 is 99. If we double check that, we say 97 or, and you can get the or operator using your shift and backslash, and you will get 99. Right? Now, we need to discuss loops. We're going to look at, like I said, the while loop. And we're going to write a very simple script or a function. Every function you write will begin with def or define. The name of the function, I'm going to call it natnum. We're going to do a natural number function which will print the natural numbers between 1 and 20. Right? And I'll say here, remember there has to be an indentation, num equal to 0. And then I will say while num less than 20. Okay. And then I will say num plus equal to 1. Okay. And then print num. Right? And that's all. Let's see how this runs. You can call this function by just typing in natnum, or execute the function by just typing that in, and we should have the result. Right? We have all the natural numbers. So that's how the while loop works. Of course, again, this is a very simple implementation of the while loop. What's happening here is within the loop, right, as long as num is less than 20, we are adding 1 and printing it out. Okay, but note that we get 20 as well because that condition is checked after the loop is performed. So while num less than 20, so print 1, 2, 3, 4 until, let's say, num here is 19, right? And it's still 19, so it prints, it adds 1, right? Then prints out 20 and then checks the condition and stops. Okay, that's important to know. So with the while loop, it will print out the result and then, check the condition. Okay, so I hope you've understood that. Any queries on this session, you can just put into the comments and I'll try to get back to you as soon as I can. We're going to end this session with a little script again that is going to clear the screen. Okay, because if I just type in CLS as I would do on Windows, I cannot clear the screen. There is no such command in Python. But before I do that, if you want to save what we've done in a file, all you need to do is just select the entire screen. Okay, whatever we've done, that is. Right? Control C. And then go to Notepad. We just bring this up. Control V. And you'll have everything saved in that. But of course, you've got to save this file. So file, save as. You can call it module1.txt. Right? And then you can save it. Okay? Just for your easy reference. Right? Now, as I said, We'll end the session with a little script. So def, and we'll call this CLS. And what we'll do here is we'll import OS. We are importing the OS module. And then of course we'll use os.system. We're calling the system method. And we'll pass to that the command we use in our operating system to clear the screen. Okay. Now if I call this function, the screen is cleared. So this ends our session for today. In the next session, we'll be writing little programs to manipulate strings. Till then, take care, stay safe, bye.